Hey guys, today we're going to be learning about the factors that affect boiling point and how we can rank different molecules by their boiling points. Before we go into that though, let's first go over why different compounds melt and boil at different temperatures. So substances like, for example, water can exist in three different states of matter: solid, liquid, and gas. The only difference between these states of matter are how tightly the molecules of our substance are held together. So solids involve molecules being really tightly held together. Since they're packed together so tightly, the molecules can't move around and the structure is rigid. Liquids involve molecules that are still held together, but they're not held together as strongly, so they can move around more freely. Gases involve molecules that are not held together at all, so they're free to bounce around and move wherever they want. So we need to keep in mind that if we don't put any heat energy into the system, our substance is a solid, since the molecules are rigidly held together by attractive forces. These attractive forces are called IMFs, which is short for intermolecular forces. So if we want to convert substances to liquids and gases, we have to add energy in the form of heat. What the heat will do is basically overcome the IMFs that are holding the molecules together. So this gives our molecules the ability to move around more freely and turn the substance from solid to liquid, and after adding more heat, from liquid to gas. So boiling points of substances basically represent how much heat energy we have to put into our system to liberate the molecules from the liquid to the gas phase. So it makes sense that the stronger the IMFs are between the molecules, so the stronger the molecules are held together, more heat is required to get our substance to boil, so there will be a higher boiling point. If we want to compare different substances' relative boiling points to each other, we first have to understand the types of intermolecular forces that can exist between molecules and their relative strengths compared to each other. So the strongest type of IMF that exists between molecules are ion-dipole interactions, which are basically when an ion is attracted to a molecule that has a dipole moment. So ions are molecules that have atoms with formal charges. So this could be a fully positive charge or a fully negative charge. Here we can see that our oxygen has a negative charge, so this here is an ion. So ions can interact with molecules that have a dipole moment, meaning molecules that have polarity. Polarity basically means that you have atoms with different electronegativities connected to each other. So in this water molecule here, oxygen is more electronegative than hydrogen, giving it a partial negative charge, which leaves our hydrogens with partial positive charges. So because of that, these bonds have dipole moments. We need to remember that opposite charges attract each other. So this negatively charged oxygen from our ion is attracted to the partially positive charged hydrogen from water. This attraction is called an ion-dipole interaction. The next strongest type of IMF is hydrogen bonding. Hydrogen bonding happens in molecules that have hydrogen covalently bound to oxygen, nitrogen, or fluorine. We need to remember that these elements are all very electronegative. So when we look at the bonds between hydrogen and any of these elements, so in our example, oxygen is a lot more electronegative than hydrogen, giving it a partial negative charge, which gives our hydrogen a partial positive charge. We always assume that there are multiple molecules of the same substance in our solution. So let's say we have two ethanol molecules next to each other here. Since opposites attract, the partially positive hydrogen on one molecule is attracted to the partially negative oxygen on another molecule. This attraction between the two molecules is called a hydrogen bond. These are very strong attractions, but they're not as strong as ion-dipole interactions, since these involve partial charges attracting each other, whereas ion-dipole interactions involve one of the molecules being fully charged, resulting in an even stronger attraction. After hydrogen bonds, the next strongest type of IMF is dipole-dipole interactions. These are just like hydrogen bonds, except they don't only involve partial positive hydrogens, but instead they also involve partial positive atoms other than hydrogen being attracted to any partially negative charged atom. So like here on this ether molecule here, we have oxygen bound to carbon. Oxygen is more electronegative than carbon, which gives it a partial negative charge, giving carbon a partial positive charge. The partially positive carbon on one ether molecule is attracted to a partially negative oxygen on another molecule in solution. This is a dipole-dipole interaction. These are strong interactions, but they're not as strong as hydrogen bonds because with hydrogen bonds, since hydrogens are very small atoms, hydrogens can get closer to electronegative atoms than other atoms like carbon can. So hydrogen bonds are shorter and therefore stronger. So the weakest type of IMF that exists are van der Waals forces, which are also called dispersion forces. Dispersion forces exist between any types of molecules, whether they're polar or nonpolar. We need to keep in mind, though, that molecules have atoms, and atoms consist of a positively charged nucleus surrounded by a negatively charged electron cloud. These electrons are constantly moving around the nucleus, so it's possible for a split second, all the electrons around the nucleus are more positioned towards one side of the atom, giving that side of the atom a partial negative charge and giving the other side of the atom a partial positive charge. So let's say we have an atom that momentarily has a side with a partial negative charge. So here, the right side of our atom, drawn in black, is partially negative. If the black atom is moving towards another atom on a different molecule, it can induce a momentary dipole in that other atom. Meaning, so for example, when these black and red atoms touch, the partial negative side of our black atom causes the electrons from our red atom to move to the other side, since like charges repel. This gives the left side of our red atom a partial positive charge. So since opposites attract, there's a momentary attraction between the black atom and the red atom. This attraction dissipates in a split second since electrons are always moving, which is why dispersion forces are the weakest type of IMF. I want you to keep in mind that the larger the surface area of a molecule is, the stronger dispersion forces it has. So for example, if we're comparing these two molecules, which have the exact same number of carbons, but one of the molecules is branched, the branched carbon chain has a smaller surface area since the structure is more condensed. So the branched molecule has weaker IMFs than the unbranched molecule. This means that the unbranched molecule has a higher boiling point. So I want you guys to keep in mind these relative strengths of IMFs because the stronger IMFs a molecule has, the higher its boiling point will be. So say we were given a question in which we had to rank all these molecules by their boiling points. So what we first want to do is look at the types of IMFs that all these molecules have, since stronger IMFs leads to a higher boiling point. So this molecule on the way left here, as well as this molecule on the way right, are just carbon chains, so they both just only have dispersion forces since they don't have any polarity. These two molecules have a hydrogen covalently bound to oxygen or nitrogen, so they both have hydrogen bonding. This molecule here has polarity because it has an oxygen, but there are no hydrogens bound to this oxygen, so it only has dipole-dipole forces. Since dispersion forces are the weakest, these two molecules will be 4 and 5, so deciding between them, these molecules both have 6 carbons, but this molecule is a branched carbon chain compared to this one, which is just straight. Branching decreases surface area, which decreases the dispersion forces, making this have a lower boiling point. So this will be number 5, and this here will be number 4. Dipole-dipole forces are the next strongest IMFs, so this ether molecule here is going to be number 3. So hydrogen bonding is the strongest IMF out of these molecules, so these two will be number 1 and 2. So when we're deciding between them, we want to keep in mind the atom that's attached to hydrogen on both these molecules. Here we have oxygen and here we have nitrogen. I want you to remember that oxygen is more electronegative than nitrogen, giving it more of a partial negative charge than nitrogen has, which gives the hydrogen attached to oxygen more of a partial positive charge than the one attached to nitrogen. So the more drastic charges are from each other, the more they're going to attract each other and the stronger the forces will be between them. So because of that, alcohols will have stronger hydrogen bonding forces, so they'll have higher boiling points. So this molecule will be our number 1, and this will be our number 2.